Okay, so guys, today we're going to be doing absolute value transformations. Let's talk about the different parts you're going to see. Inside of the absolute value bars will determine the direction X. So either it's going to go left or right. That is the X direction. So if you have a minus sign, it'll go to the right. And if you have a plus sign, it will go to the left. On the outside, if you have a plus, it'll go up, and if you have a minus, it will go down. So on the inside, it's a little bit opposite of what you would think. This A value in the front, if the absolute value of A is greater than 1, it'll be a vertical stretch. If your absolute value of A is less than 1, it'll be a vertical compress. The last thing I'm going to add is if there's a negative sign in the very front, we're going to say that is a reflection. So it will reflect over the x-axis. Some definitions. A translation is when your graph is slid to the left or the right, or shifted when it moves up, down, left, right. A dilation is when it stretches or compresses. It gets bigger or smaller, it shrinks, it gets larger. Those are dilations. And what do you think the last one is? What'd you say? A reflection, good. A reflection, that's when it flips across the x-axis, or it could be the y-axis. This class we're going to be doing the x-axis. All right, so let's try these transformations. According to your notes, you have a plus sign inside the absolute value symbols. How did this move? Left. Good, left 2. Okay, this one over here, we have a minus on the inside. How did that move?
Right 2.
There we go. All right, now we're outside of the absolute value symbol. What did this do?
Up 2.
Yep. And this one?
Down 2.
Down 2. All right. Here, we have a value greater than 2. What did we call that? Vertical stretch by 2. Here we have a 1/2 that is less than 1. We call it a vertical compress by a 1/2. And our last one, we have a negative in the very front. What do we call this?
Reflection.
And you're going to reflect over the x-axis. Okay, so we're going to go over this one on your page. This negative is going to make it reflect over the x-axis. So normally your parent function, it looks like this. However, now it's going to be facing down because of that negative in the front. Okay? Next, you have a negative 2 here. The absolute value of negative 2 is a positive 2. That's greater than 1. So you have a vertical stretch by 2. So now your slope is not going to be up 1 over 1. It's going to be down 2 over 1. Down 2 over 1, right? Like that. Okay? And then also right here, what happens there? Yep, right 1. So these points will shift over to the right 1. So your transformation, if we do it in order, well, if you do all of them, it's going to be facing up like this. Then it's facing down. The slope changes and it moves to the right 1. So those are all of the transformations. Here's another example that's on your page. I believe this is number 22 that you did. Vertical compression by a factor of 2/3. So it'll look like this. 2/3 is in the front. It didn't move left or right, so there's nothing on the inside with X. And it didn't move up or down, so there's nothing over there. And then it's reflected over the x-axis, so you need a negative in the front. So normally, this is your parent function. However, it's facing down and your slope is now 2/3, so down 2 over 3. Down 2 over 3 on both sides. So this would be your new graph. Make sense? All right. So guys, go ahead. We're going to flip the page and do some more practice. We're going to practice graphing now. Okay, first example that we're going to graph. What's the transformation in here? Good. Write that down. Write 2. And this is down 4. That means your vertex is 2 and a -4 because it went right 2, down 4. So guys, these numbers will always determine your vertex. How it moves left and right, up and down, determines your vertex. So let's go ahead and plot this on the graph. 2, -4 is down here. And you don't have an A value. Your A value is just 1. You can imagine a 1 there. So your slope is just up 1 over 1, up 1 over 1, just like this. And then do it for the other side. Okay, so that's your V-shaped graph. And just a question, guys. The domain. What is the domain for this? All real numbers. It goes forever left and forever right. No matter if it's facing up or down, it's going forever left and right. So it will always be all real numbers for these absolute value graphs. Now, your range is a little bit different this time. Your range is down here at -4. So you're going to put -4 with a bracket, and then it just goes up from there. That's infinity. So guys, we call this interval notation. If you did set notation, you would say y such that y is greater than or equal to -4. Because if you notice, here is -4 and everything is above it. So we say everything is above, greater than or equal to -4. So this is set notation. Okay? All right, let's try another one. We're going to do number 2 next. So number 2, and we're going to talk about all of these things with this example. This went left 5. I'll write it for transformations. It went left 5, and it did a vertical what? Stretch. Yep, a vertical stretch by 3. Okay, so guys, if it went left 3, my vertex will be a negative, it went left 5, so my vertex will be a -5. Did it go up or down? Nope, so it'll be a 0 there. So I'm going to go ahead and plot my vertex, -5, 0. 1, 2, 3, 4, 5, right here. And what's my slope? 3. This number right here is your slope. So I'm going to go up 3 over 1, up 3 over 1 on this side, and the same way on this side to create my V-shaped graph. Okay, so your domain is always going to be all real numbers. My range, the very bottom is right here. That's at 0. For the y's, that's 0 on the y-axis, 0. So that's 0 to infinity. And if you wrote it in set notation, you would say y is greater than or equal to 0. Okay, let's talk about the maximum on this given interval. If you look between -7 and -5, let me highlight that for you. -7 is 1, 2, 3, 4, 5, 6, 7. -7 is right here, and -5 is right here. What is the maximum between these two x values?
6.
Right here? Yep, that's at 6. 1, 2, 3, 4, 5, 6. I only need the y value, so that maximum is at 6. What's the lowest part between these two lines?
0.
0. So that's the y value, 0. I only need the y value for maximum and minimum, okay? Axis of symmetry. So guys, symmetry means if you split it right down the middle, this side mirrors this side, just like your face. So in art class, symmetry, symmetrical, both sides are the same. So guys, where is the line that would split my graph right down the middle? Yep. Good, you gave me the point. It's at -5. So the equation of this line, this is the axis of symmetry. The axis of symmetry is at x equals -5. This is the x-axis and it crosses it at -5. So the answer for axis of symmetry is x equals -5. I need the equation of the line. X-intercept. Your x-intercept is right here. And that happens to be the vertex as well. So that's -5, 0. And your y-intercept is where it crosses the y-axis. It's kind of off of the page, but we can kind of guess if we kept going. It'll be here, and then next it'll be here. So that's 6, 7, 8, 9, 10, 11, 12. So that's at 0, 12. Okay, so another way you can find the y-intercept is if you plug in 0 for x. So if you plug in a 0 for x, what's 0 plus 5? 5 times 3? Wait, we got 15. It should be 15. Let's see. Oh, I'm sorry. I did up 1 over 1. What's our slope? 3. So let me do that again. If you went up 3, you'd be here. And then up another 3, you'd be up here at 15. Okay? So another way to figure out the y-intercept, just plug in 0 and then find your answer. Any questions on these guys? All right, so you guys are going to practice on your own. We have lots of equations you can graph. I'm going to put them on the board as well.
Is this due?